In today's video, we'll travel to the Netherlands to see a treehouse construction project by a talented craftsman. What makes this project interesting is that the builder did not start by constructing the house, but by studying how the tree would interact with the structure over many years. That is a major difference between a short-term DIY project and a structure designed to survive for decades in a natural environment. Before cutting a single piece of timber, he spent considerable time measuring, because even small errors at the beginning can become much larger as the structure rises. In structural woodworking, precision is not only about appearance, but also about how loads are transferred through every part of the building. The hand-cut joinery shows that the builder wanted strong mechanical connections between timber members rather than relying entirely on metal hardware. When two wooden surfaces fit together accurately, forces are distributed more evenly, and the lifespan of the joint improves significantly. This type of thinking is often seen in craftsmen with traditional woodworking backgrounds rather than builders who depend mainly on screws and bolts. One of the biggest challenges in building a treehouse is accepting that your foundation is actually a living organism. Unlike concrete or steel, a tree constantly changes in size, shape, and behavior as it responds to seasonal weather conditions. That is why the metal connection system was designed with controlled movement instead of rigidly locking the entire structure to the tree. This approach helps reduce stress buildup when the tree sways in the wind or continues growing over time. Many tree houses fail not because the materials are weak, but because the builder tries to force nature to follow a fixed design. The builder in this project does the opposite by adapting the design to the characteristics and behavior of the tree. Large anchor bolts are installed at strategic locations to concentrate loads on the strongest load-bearing areas of the trunk. Using fewer anchor points that are carefully engineered is often more effective than creating many smaller connections that damage a wider area. When the primary support beam is finally positioned, it marks the moment when the skeleton of the entire structure begins to take shape. All future loads from the floor, walls, roof, and occupants will ultimately be transferred through this critical beam system. Even a minor alignment error here can lead to sagging floors or structural twisting after years of use. The use of temporary clamps before fully tightening the bolt shows that the builder values accuracy more than construction speed. This is an important principle because correcting mistakes before the structure is fully locked together is always easier than making repairs afterward. A structure may be capable of carrying heavy loads, yet still feel unstable if its movement is not properly controlled. Diagonal bracing redirects forces through the frame and helps prevent deformation when uneven loads are applied. Although these components often go unnoticed, they play a critical role in how solid and stable the finished treehouse feels. As diagonal braces begin to appear beneath the floor platform, the structure gains a much greater ability to resist twisting and unwanted movement. It is clear that the builder is creating a structural system that works as a single unit rather than a collection of separate parts. The addition of ground-supported posts suggests that he does not want the entire long-term load to rest solely on the tree. This approach allows the weight to be shared between the natural support system and the man-made structure, improving overall safety. The support posts sit on raised concrete pads instead of touching the soil directly, reducing the risk of moisture absorption from below. Long-term moisture exposure is the real enemy of timber, far more damaging than occasional rainfall as many people assume. As the large beams are lifted into their final positions, the true shape and proportions of the treehouse begin to emerge. This stage requires excellent balance and accuracy because even a small error can alter the path through which loads travel. Horizontal support members are inserted into pre-drilled holes to lock the framework together in multiple directions. Before installation, the timber ends are treated with protective oil to reduce the effects of moisture and insect activity. It may seem like a minor detail, but this treatment often determines how long the material will survive outdoors. Experienced builders understand that durable structures are created through hundreds of small decisions rather than a few impressive features. As the upper timber beams are connected beneath the roof structure, the project begins transforming from a collection of separate members into a unified load-bearing system. What stands out is that every bolt and connection serves not only to hold components in place, but also to increase the overall rigidity of the structure. The lower braces continue to connect with newly installed members, showing how the builder is gradually creating a balanced load distribution network in both directions. The precisely drilled holes between the posts do more than accommodate cross braces. They create strong connection points that help reduce movement under load. Before installation, the ends of the smaller timber pieces are treated with tung oil, a natural protective finish that resists water, insects, and long-term weathering. Once the oil has fully penetrated the wood fibers, the members are placed into position and secured with nuts and bolts for long-term structural reliability. Additional timber pieces are cut with a high level of precision to maintain alignment throughout the structure, because even small errors can affect the final geometry. Before completion, another protective coat is applied to the timber surface to shield it from moisture and rain while improving long-term durability outdoors. Reinforcement details continue until the floor frame is completed, transforming it into a solid structure ready for the next stage. The floor joist installation marks the point where the structure begins transitioning from a basic support frame into a platform capable of carrying the construction phases that follow. Each joist is positioned according to carefully calculated spacing to ensure that floor loads are distributed evenly across the primary support beams below. It is clear that each joist end is securely connected to the main beams, creating a unified load-bearing network rather than a collection of independent structural members. This stage often reveals the true quality of the structural work because any mistake in joist placement will affect every construction element installed above it. Once the joist system is complete, the structure has a solid foundation for the installation of flooring, walls, and other architectural elements in a safe and stable manner. When the first floor layer is installed, it serves not only as a usable surface, but also as a test of the frame's overall accuracy. In timber construction, flooring often reveals alignment errors because any irregularity in the beams becomes visible on the finished surface. One notable decision is leaving clearance around the trunk instead of forcing the floorboards tightly against a tree. This reflects long-term thinking because a healthy tree can increase significantly in diameter over the years. Without that planned gap, the structure could eventually restrict the tree's growth, or the tree could damage the floor itself. The next phase focuses on the staircase system, a component that is often underestimated despite its importance to everyday usability. Rather than using a conventional straight staircase, the builder chooses a spiral design around a central column to save space. This solution works particularly well in a treehouse, where the available ground area is often limited by terrain and surrounding trees. The central steel column acts as the backbone of the staircase and carries most of the loads generated during use. A closer look reveals that the steps are spaced evenly to create a natural walking rhythm and improve user safety. A beautiful staircase is not necessarily a good staircase, but one with proper proportions almost always provides a better experience. Once the staircase is complete, the connection between the ground and the living space above becomes fully established. This is also the moment when the treehouse begins to evolve from a technical structure into a truly usable building. The wall framing process begins with the careful positioning of vertical posts and the planned openings for future windows. These openings do more than provide natural light because they also influence the overall rigidity of the wall system. In timber construction, every window opening requires the load paths around it to be recalculated and reinforced accordingly. This is why additional structural members are often installed above and beside window openings to carry loads safely. The builder repeatedly checks the plumb alignment of the frame because small deviations at this stage can affect every finishing detail that follows. As the wall sections gradually rise into place, they begin functioning as structural panels that significantly increase the overall rigidity of the building. This is one of the reasons a timber structure often feels much stronger and more stable once the wall system has been completed. The first cladding boards do more than define the appearance of the building because they also help tie individual framing members into a unified structure. The more correctly placed connections that are added, the better the building becomes at resisting movement and vibration. From an engineering perspective, this is the stage where the project transitions from an open frame into a complete structural system. With the basic wall framework finished, the builder turns his attention to one of the most important components of the entire project, the roof structure. A roof does far more than provide shelter because it ultimately determines how well the building will withstand long-term exposure to the elements. Triangular roof trusses are chosen because this geometric form offers exceptional stability and efficiency in structural design. A triangle is extremely resistant to deformation when its sides are properly connected, which explains its widespread use in roof construction. The precisely cut angles at the ends of each timber member demonstrate the builder's understanding of load distribution throughout the roof system. Even a small error in these cuts can cause forces to travel unevenly and reduce the long-term durability of the entire framework. As the trusses are raised one by one, the project begins to resemble the vision that existed only on paper at the beginning of construction. Additional horizontal members are installed not only to secure the roof, but also to prevent unwanted movement across the structure. This detail becomes especially important for elevated buildings that are regularly exposed to wind and changing weather conditions. It is evident that nearly every component has been designed to work together as part of a coordinated structural system rather than as isolated elements. The roof reinforcement phase begins as additional bracing members are installed between the primary load-bearing components to increase the rigidity of the entire upper structure. This is a particularly important step because the roof must withstand not only its own weight, but also continuous exposure to wind, rain, and changing weather conditions. Diagonal braces are positioned at strategic locations to reduce twisting and unwanted movement within the roof frame when uneven loads are applied. It is clear that the builder is creating multiple load paths so that structural forces are not concentrated on only a few individual connection points. Every bolt and joint is carefully inspected to ensure that the entire roof system functions as a unified structure rather than a collection of separate components. When the roofing material is finally installed, the structure gains its first meaningful level of protection against the outdoor environment. A well-designed roof is always intended to move water away from the building as efficiently as possible rather than allowing it to accumulate. With the primary structural work completed, the builder shifts his attention to details that may seem secondary, but ultimately define the quality of the finished living space. The balcony is a perfect example because it not only expands the usable area, but also strengthens the connection between the occupants and the surrounding landscape. By examining how the balcony posts are installed, it becomes clear that loads are distributed through multiple pathways rather than concentrated at a single point. This approach helps reduce stress concentrations, one of the most common causes of cracking and structural failure in outdoor timber construction. The natural tree trunks used as support posts provide more than visual appeal, because solid timber offers excellent compressive strength when used correctly. However, the real performance of any material depends not only on the material itself, but also on how effectively it is integrated into the surrounding structure. The installation of the windows marks an important transition as the project begins to feel like a genuine living space rather than a purely structural framework. From an architectural perspective, windows do more than provide daylight because they establish a visual relationship with the surrounding environment. A well-positioned window can dramatically transform the perception of a space without increasing its physical size. One notable detail is that the window openings were incorporated into the wall framing from the beginning rather than being added afterward. This approach preserves structural continuity and minimizes the risk of introducing weak points into the framework. With the major structural elements complete, the project enters the finishing stage where patience often becomes more important than physical effort. Many people underestimate this phase because it produces fewer visible changes, yet it serves as the first line of defense against weather and aging. Protective oil coatings help shield the timber from moisture, ultraviolet radiation, and biological agents that can gradually degrade the material. In a forest environment where temperature and humidity fluctuate constantly, preserving the integrity of the timber becomes essential for long-term durability. A quality finish does not make wood inherently stronger, but it helps maintain its original structural properties for a much longer period of time. As the balcony roof reaches completion, this area gains far greater protection from the elements and becomes a fully functional part of the overall structure. Beyond providing shade, the balcony roof helps reduce the amount of rainwater reaching the deck and supporting posts, extending the lifespan of the materials below. The roof supports are tied together into a unified framework designed to distribute wind loads efficiently and minimize structural movement during harsh weather conditions. With the roof structure secured, the builder shifts attention to the balcony floor system, which will eventually carry the daily loads of future occupants. Each deck board is carefully cut and aligned to maintain consistent spacing, improving both the visual appearance and the natural drainage performance of the surface. A good finish doesn't make wood stronger, but it helps maintain the wood's inherent mechanical properties for a much longer period of time. As the final exterior cladding is installed, the structure begins forming a complete protective shell against the forces of the surrounding environment. This outer layer is exposed directly to sunlight, rain, wind, and temperature fluctuations, making precision just as important as in the structural frame itself. The trim pieces added along the joints reveal that the builder is addressing one of the most critical challenges in construction, controlling the path of rainwater. In outdoor building projects, water almost always finds a way in, and the designer's job is to guide it along routes that cause the least possible damage. Small finishing details often go unnoticed when a project is new, yet they frequently determine how well it resists deterioration over the years. What makes this project worth studying is not the use of advanced technology, but how effectively it applies the fundamental principles of sustainable construction. Most design decisions revolve around managing loads, moisture, and the natural movement of materials, rather than focusing purely on appearance. This mindset is what separates a structure that survives for only a few years from one that can remain functional for decades. It is clear that the builder consistently focuses on solving root causes rather than dealing with problems only after they appear. For example, elevating support posts above the ground is far more effective than repeatedly replacing posts damaged by rot in the future. In the same way, allowing the tree to grow naturally is more practical than attempting to restrict its development through artificial solutions. The more a structure respects and adapts to natural processes, the greater its chances of surviving successfully in a natural environment. Viewed as a whole, this treehouse is not especially large, yet it features a structural system that is carefully balanced and intelligently engineered. Every component, from beams and columns to floors, walls, and the roof, serves a specific role in transferring and distributing loads. That is why the building feels remarkably solid even though most of its materials are made from natural timber.